Imagine two invisible giants, each a devourer of light, locked in a cosmic dance across billions of years. Slowly, orbit after orbit, they draw closer. Their gravitational embrace twists reality itself. And then, the inevitable. A collision so violent, it shakes the very fabric of space-time. What really happens when two black holes merge? The answer is one of the most extreme and most beautiful events in the universe. Black holes are the collapsed remains of massive stars. When a giant star burns through its fuel, gravity wins. Matter is crushed into a point of almost infinite density, the singularity. Around it lies the event horizon, the ultimate point of no return. Not even light can escape. Some black holes weigh just a few suns. Others, supermassive ones, sit in the hearts of galaxies, billions of times heavier than our sun. But what happens when two of these monsters find each other? For decades, Einstein's theory of relativity predicted the answer. They would send ripples through space-time, gravitational waves. But these waves are unbelievably faint, stretching space by less than the width of a proton. Even Einstein doubted they could ever be found. And yet, in September 2015, we did. Two black holes, a billion light-years away, spiraled together. Their final collision sent a ripple racing across the cosmos, finally brushing past Earth. At the LIGO observatories, two massive L-shaped detectors, laser beams kilometers long shifted by less than a hair of a proton. It was just a tiny chirp, but it was enough. Humanity had, for the first time, heard the universe through gravity itself. So what really happens during the merger? Stage 1, the inspiral. For millions of years, the black holes circle each other, slowly tightening their orbit as they radiate gravitational waves. Faster, closer, until finally, they're spinning around each other at nearly half the speed of light. A cosmic waltz of death. Stage 2, the merger. In less than a heartbeat, the horizons touch. Space twists. Energy erupts. For a brief moment, the collision releases more power than all the stars in the observable universe combined. No light, no explosions, just a ripple in the very fabric of space-time, racing outward at the speed of light. Stage 3, the ringdown. The newborn black hole trembles like a struck bell, sending out more waves until it settles into silence, a larger, smoother, eternal giant. Since that first detection, we've caught dozens of these events. Some involve small stellar mass black holes, others giants. And with every detection, we learn how common black holes are, how they grow, and maybe even how the monsters at the centers of galaxies were born. Could repeated mergers, small ones joining into larger ones, be the origin of supermassive black holes? Imagine a cosmic chain reaction, building monsters that shape entire galaxies. But the mysteries go deeper. Do all black holes behave exactly as Einstein predicted? Or could tiny differences in the signals hint at new physics? Something beyond relativity, maybe beyond space and time itself. These collisions aren't just violent. They're laboratories, letting us test the universe at its most extreme. And here's the awe-inspiring part. Black hole mergers are happening right now, all across the cosmos. Some ripple is already on its way, traveling silently through space. One day, years or even millions of years from now, it will wash across Earth. Our instruments will tremble, and once again, the universe will whisper its secrets. So, what happens when black holes collide? Space-time itself quivers, energy ripples across the cosmos, and a new, more massive black hole stands as the silent witness. The next time you look at the night sky, remember, somewhere out there, two invisible giants may already be spiraling toward their fate, and when they finally collide, the universe itself will shudder. If you enjoyed this journey, make sure to subscribe, because the cosmos is full of mysteries, and together we'll uncover them.